All right, today we want to talk about the EM, electromagnetic spectrum. I'm going to sign spectrum like that. It's a wave, and it's made by vibrating electrical charges. EM's waves can travel through anything. They don't need a medium. Do you remember that word? It means a material. None is required for an EM wave. So EM waves can go through space. It doesn't have to go through a liquid or a solid or a gas, none of that. But an EM wave can go through space. So frequency means that speed of a wave, how many waves are going by in 1 second. You remember amplitude, that's the height of the wave. And then it shows how many waves are going by each second and how many are traveling by. So that spectrum, as you can see, there's a whole spectrum along here. And there's different things at each of those areas along the spectrum. And each one of those show a different frequency. So on the top, you see wavelength right there. Wavelength. Remember when we talked about exponents? Negative exponents are small. It's meaning something really, really, really small. So like radio waves travel through the air at 10 to the third wavelength. So that's actually a pretty big wave. It's got a long wavelength. So there's some differences there. I'm going to explain and expand on each one of those different kinds of waves along the spectrum. The part that we can see, the visible light, it's actually really small. But there's other waves, larger and smaller than what you can see, that you can't see. It's a whole spectrum along there. So first, I want to look at radio waves. It's a really low frequency. It means it's very slow. It's 1 to 10 centimeters in length. There we go. Radio waves. And they spread out in all directions, 1 to 10 centimeters. That's also a microwave, is about that same size of a wavelength. Or like when a police is watching for speeders, using a gun, radar gun, or sonar, like on boats. They're sending down signals, they're looking for fish, and they can see that on a little screen. And then infrared wave, it's not really red, the sign red, because you can't actually see it. But I've seen some people sign, red, and for infrared, it's not something you can see. So that frequency is a little bit higher than radio waves. Like you use a TV remote, or you see the warmth from a fire, or the warmth on someone's skin. And then, you can feel the warmth from the sun. That's those infrared waves. There are some special cameras that will show infrared, and it shows different colors for the different temperatures. It's kind of some cool equipment. And then there's what we call visible light. So those are the things that humans can see. And it goes all the way for violet. all the way up to violet. From infrared, and in between infrared and ultraviolet is the visible light. That infrared is right before the red part that you can see. And you can see those colors: red, orange, yellow, green, blue. And then be careful, because it's indigo. We don't sign purple, it's indigo. And then the last one is violet. So those are the colors, and they're in order. You have to follow that order. If you notice, every rainbow, actual rainbow in the sky and stuff, will be in those colors in that order because of the frequency of the different colors. So then beyond the visible light is the next one is ultraviolet. It's a little bit faster than the violet that you can see. So when you get a sunburn, you get red from the sun, that's the UV. Well, you get vitamin D also from that UV light. It's light that can help to kill bacteria, which is kind of cool. UV light can help kill bacteria. And there you go. You see a sunburn there. And then next to ultraviolet is X-ray. So like if you have a broken bone and you need an X-ray to see what's going on there. So next to that is the gamma rays. Gamma rays can actually go through things. The X-ray, you have to be careful even with X-rays. For example, like if you go to the dentist and they take an X-ray of your teeth or something, you put on that heavy lead blanket kind of thing, goes on your chest, and it actually protects your internal organs, your heart and stuff. It is dangerous. If you get exposed to X-ray over and over and over again, the people who run the X-ray machines, do they stay in the room when you're getting an X-ray? Nope, they go out of the room, they're protected, and then they come back in the room. So they don't want to be constantly exposed to X-rays all day long. It would really cause some problems for them. If you get too much radiation, you can get cancer from that. Things that destroy cancer as well as cause cancer. Radiation rays can do that. The Hulk from our superheroes, why he becomes green and a big Hulk like that, it's from radiation. And I think he had gamma radiation. So here's a great picture showing what can stop different kinds of rays. So that heavy metal, that's the only thing that can stop a gamma ray. So that's the EM spectrum. Make sure you put them in your notebooks and information about this, and also fill out this sheet here that I've given you. Cut these out on the side and put them in the right place on the waves. Add some color in there to the visible light, the rainbow there. And make sure you have those in order. And you can color it, make it look nice. All right?